So, friends, we are now resuming today with altogether a new area and a new topic. We have completed the protection of transmission line using overcurrent and earth fault relays. But on the same overcurrent and earth fault relays, how to work in laboratory environment, that we would like to see. My dear friends, I have worked in Engineering Institute for 26 long years and have seen many engineering colleges in Gujarat state. And I have found that there are many laboratories. Machine laboratory is everywhere usually available. Measurement laboratory is usually available. First year basic electrical engineering laboratory is available. But power systems lab and power system protection, particularly power system protection lab, is either not available or if it is available, it is underutilized. That is my opinion. I may be wrong. I don't say that I'm 100% correct. But with all my experience, I've seen these things in many of the institutions. Mostly in power system protection, people do the experiments. That means the teachers are giving the experiments of study of uh, electromagnetic disk type overcurrent relay, IDMT overcurrent relay, study of distance relay, study of Buchholz relay. All these studies are done. That means the student is asked to refer to the book or some ready-made paper is given and he has to simply copy. And then no doubt some Buchholz relay may be available in the laboratory and teacher might be showing. But a full-fledged experiment where the student will really do the experiment, will take some readings, will do observations, will do some calculations, will do some relay settings, will plot graph. You see, all these things I have not seen in most of the colleges. In Birla Vishwakarma Mahavidyalaya, PVM Engineering College, Vallabh Vidyanagar, we have developed a very good laboratory which is renowned in Gujarat. If I say it is renowned in India, then also it is not wrong, because one person, one professor who had come to give the accreditation, I mean, he had come for accreditation purpose, whether we should be given accreditation or not. He made a remark that he has visited some 40 institutes all over India and he has not seen the laboratory of this kind. That is the certificate given by him. So I can certainly say that in India also such a good laboratory is not there. And we have designed some 60 experiments. You see, you can understand that power system protection and advanced power system protection, if you take and every time you do 10 experiments each, then you can do 30. You cannot do 60 experiments. So for those 60 experiments, I was taking extra sessions to carry out the experiments. So many real experiments were done, you see. And I am of the strong opinion that when you go to laboratory, when teacher goes to the laboratory, he will not talk anything about theory. He will talk about practice only. He will talk about practical only. He will ask the students to draw the circuit or to connect the circuit, to take the readings, to plot the graph and everything. So this is what my opinion is with reference to laboratory. And therefore, you see, I think the viewers of the YouTube of Adapt Me channel will be really happy to know this. Any engineering institute can design the experiment and at very low cost. That is very important. You see, nowadays the number of students, particularly the electrical discipline, are very small, where there is a strength of 60 students allowed. Hardly 20 or 23 seats are fulfilled. Very good institutes like Nirma and PDU also, they're finding difficult to find the full number of students for electrical discipline. No doubt CPIT are getting full. I mean, they are completely full. There is no vacant seat. But in electrical, and electrical is a very important branch. I can dare say that without electrical you cannot live. How will you run the power plant? How you will transmit electricity? How you will distribute electricity? How you will run the industry without induction motor? You see, electricity, how you will be in your house? How will be there light? How will you see the TV? How will you heat up the water? You see, at every place you can't live without electricity, and electrical engineer is a must. And it is very rather unfortunate that electrical engineers are not required. People are not preferring electrical branch. I don't understand. But then, you see, because the laboratories are not well equipped, and because the problem of funding is there, people cannot spend money. So now I am showing to you a very low cost laboratory, my dear friends, and I think you will find interest in this. So the first experiment, we start with testing of overcurrent relay. How to test the overcurrent relay. So going further to this, my dear friend, what is the motivation? Why should we do this experiment? Very important thing is, if emitter is not working, you will immediately come to know, because it will go to zero. And if you are seeing the wattmeter, it is showing some power, but current is showing zero, right? You are seeing the voltmeter, voltage is showing, but current is showing zero. Circuit is complete. So you will come to know that emitter is not working. But for relay, unfortunately, relay does not work under normal condition. Relay works when fault occurs. And fault occurs once in a week or once in a month. That also for 2 seconds or 3 seconds or 1 minute or 2 minutes. So only during that short time you will come to know whether the relay is working or not. If the relay is not working, if the relay does not work, then it will not give signal to the breaker. Breaker will not trip, and the equipment that is being protected will be damaged, or some backup relay will work. Then only you will come to know that relay is not working. Otherwise, you do not have any, rather, any idea about relay not working. So what all you can do is, in the era of electromechanical and static relays, what you are doing is you are testing periodically. So you may test the relay every year or every 6 months, right? And you will check up whether its characteristic is correct or not, time of operation is correct or not, whether the relay is behaving according to what we require or not. That you will test. But that is also not sufficient. You are testing every 6 months. Today you have tested and tomorrow it has gone out of order. That you will come to know only after next 6 months. If nothing happens, or otherwise if something happens and the equipment is blasted, if the equipment is damaged, then only you will come to know. So that is also not a good idea. But I mean, then that's all what you can do. About numerical relays, there is a very good important facility is they are having self-diagnostic facility. They test themselves, they test their software and hardware part every moment, every second. And if something goes wrong, it will give a signal, it will show the LED, it will sound an alarm, or even you can trip the breaker that is being uh, that is being tripped when the fault occurs, right? And on the display panel, some number will be displayed. and you will come to know what kind of error is there, what kind of trouble is there. That is known as IRF, internal relay failure facilities is there. But yet even people are testing numerical relay because you see, you would want to see whether the relay is working according to its parameters or not. So numerical relay is also tested. So testing is a must. Testing is a must. So to test a relay, this is a very good motivation, right? And therefore you should learn. I am always telling that learning in practical or theory, not because it is in the syllabus, not because you have to pass out, not because you have to get good grade, but you have to use it. But because you have to apply it in the field. That is why you should learn. See, why should you learn? Hmm? Why at all? Learning is required. That is very important, you see. Learning is required because you want to apply it, not because it is in the syllabus. Syllabus are different in different universities. So testing, uh, people are doing using test kit. Test kits are being manufactured by all renowned relay manufacturers. Earlier, people were manufacturing analog testing kit, say English Electric, or now they are telling Schneider. They are manufacturing for overcurrent relays test kit type CFB. We had purchased once upon a time in 45. Once upon a time in 45,000 rupees, but now it is about 2 lakhs of rupees. But the Omicron or uh, more versatile test kits are costing about 45 lakhs of rupees. I don't think any institute can bear this much of cost. Whereas what I am suggesting, it will not give many facilities. That is true. But for the purpose of testing, for the purpose of showing to the students that how does the relay behave, that is sufficient. And another very important thing, I have seen that the experiments are usually in all colleges 2 hours duration. I have seen that teachers are completing the experiments within half an hour or 45 minutes or an hour. Remnant of our students are free, students are also happy, teacher is also happy. Teacher is getting salary for 2 hours and he is enjoying the hour of time of his own. So that way teacher is also happy, student is also happy because student gets free time. He can go for a cup of tea and enjoyment, right? Everybody is happy. And if some self-finance institutes, because the management is pressing, what they will do? They will complete the experiment within 1 hour. But within remnant 1 hour, they will ask the student to read or to write something. They will give a paper. Copy karo isko. Prepare the journal right now. Get it signed. But real experimentation is not being done. That is my point of worry. So I have I have means in BVM Engineering College, we have developed a very good test kit, and in other engineering colleges also some equivalent test kits are being developed. I am going to talk about one such test kit, my dear friends. So going further, what is the aim of our experiment? We would want to test the overcurrent relay and we would want to plot its characteristic. We will plot time versus PSM. PSM we have talked about. Plug setting multiplier. Plug setting multiplier means fault current upon plug setting. Characteristics are not plotted in current versus time. It is plotted time versus PSM, plug setting multiplier. That is generalized, right? So time versus PSM we will carry out. So at PSM equal to 2, if time of operation should be 10 seconds according to theory, that means there is a formula for that. Standard formula is there. Say for normal inverse relay, 3 upon log 10 PSM into TMS. So it should give at TMS equal to 1 and PSM equal to 10 seconds. But if it gives 9.5 seconds, then that is an error. Now you should check up whether that error is allowable or not. Standards say that error in pickup. Pickup means I have set the relay for plug setting 1 ampere. Then it can pick up anywhere from 105 to 130% of plug setting. That means if 1 ampere is the plug setting, then it can pick up anywhere from 1.05 to 1.3. That also you can check up in this test set. Slowly increase the current from 0.9, 0.95, 0.98, 1, 1.01, 1.02, 1.05 and check up whether it is picking up in the region 1.05 to 1.3, then it is okay. You cannot doubt it. Otherwise, there is something wrong with the relay. Similarly, at PSM2, time of operation is 10 seconds. At PSM10, it is 3 seconds. If it is not, then what do the IS say? Standards say that up to PSM2, the time is not defined. Relay should operate. That is only standard is telling. From PSM2 to 4, the time error allowed is plus or minus 12.5%. Accuracy is not important. Reliability, relay must operate. So 12.5% plus or minus. And from 4 to 20, plus or minus 7.5%. Time error is allowed. Time tolerance is allowed. Right. Beyond 20, we don't talk because beyond 20, the time of operation is constant. It is IDMT relay, inverse definite minimum time over current relay. So this is the aim of our experiment, right? So as I told you, we will not go much about theory. When we are talking about practical, we should talk about practical only. So little of theory. That for experiments of plotting of characteristic of surveys, test set is mounted and wired on a practical panel in Power System Protection Laboratory of Electrical Department of the Institute. What is the problem with our test set? Very cheap, very economical, but the output cannot be guaranteed to be perfectly harmonic free. The standard says that the current that you are feeding should be exactly fundamental. 3% third harmonic, total harmonic distortion, not third, THD, total harmonic distortion of 3% is allowed. But this test set may give a little more. But for demonstration to the student, it is all right. You see, if you cannot spend 45 lakhs of rupees and if you can spend only 5,000 rupees, then this is okay. So the only disadvantage is perfectly harmonic free test. Current current wave shape is not possible. That is the demerit of this test set. Which relays you can test using this test set? Single phase or three phase IDMT overcurrent and earth fault relays, giving either normal inverse, very inverse, extremely inverse, long time inverse. Any characteristic you can check using this test set. Single phase or three phase instantaneous overcurrent relay also you can check. Single phase or three phase definite time overcurrent relay. Definite time means if the current exceeds 1 ampere, time of operation is 2 seconds if you have set at 2 seconds. 2 ampere, 2 seconds. 3 ampere, 2 seconds. 4 ampere, 2 seconds. I'm sorry, those who are not understanding Gujarati, they will not be able to understand. They will have to ask somebody what is the English equivalent. I don't know English equivalent, but I say that definite time overcurrent relay is takeshere baji, takeshere khaja. There is no difference. That is not required. Actually, what we require is if the current is large, fault current is large, the equipment is going to be damaged faster. Therefore, the time of operation should be faster. And if the current is less, time of operation should be less. Time of operation should be more. If the fault current is less, time of operation should be more. बारણું બંધ કરો. બારણું બંધ કરો. તરત. Time of operation. I'm sorry, my dear friends. I'm sorry, I should be excused. Time of operation should be less. If the current is more and if the current is less, time of operation should be more. Why more? Because you see, most of the faults are transient. If the fault current is less, your normal current is 100 ampere and fault current is 200 ampere. It can be withstood for 10 seconds. Then you should trip after 8 seconds. Not within 2 seconds or 1 second, because within 3 seconds or 4 seconds the fault may go away. That is the required. Therefore, inverse characteristic is the best characteristic. But yet, definite time characteristic have certain applications. What applications that those have, that we have discussed in theory in module 3 of power system protection, which is uploaded on Adapt.me, and I have been continuously telling that you must spend money, because for getting knowledge one has to spend money. You see, you want to get knowledge, you are spending money. BVM Engineering College, you have to pay 1,000 or 2,000 rupees per year because it's a government college. Right? LD Engineering College, you are paying less, but then also you are paying. But if you go to PDEU, they are asking 2 lakhs rupees. So, without payment, you cannot get knowledge. However, this knowledge that I am giving on YouTube videos is free of cost. Right? So, if you want to learn theory about all these things, that is given in module 3 of Adapt.me, power system protection, and I have written everything. There are questions also, there are theory also, there is everything. You can test single phase or 3-phase thermal relay also, and you can test numerical overcurrent relay also. For testing the circuit of figure 1, which is given in the next slide, you can use a very simple circuit. And on the panel, the output of MCB is brought on 15 ampere 3-pin socket. So auto transformer input is only so that pin, 3-pin plug, that plug has to be inserted into the socket and your current is available. Control circuit is permanently wired. You have not to wire it every now and then, because then it would take time. Only power circuit, and power circuit is also partially permanently wired. Partially you have to wire it. So what is the AC circuit, my dear friends? This is the AC circuit. 230 volt single phase AC supply is coming to single phase auto transformer. If you want to know the capacity, I think 8 ampere auto transformer is more than sufficient. Input 230 volt AC, output 0 to 270 volt AC. I repeat, the specification. No doubt, specification is not only this much. There are about 8 to 10 specifications. Somewhere I have given specification. In some other experiment, I will be giving you detailed specification, but short specification. Input 0 to 230 volt, output 0 to 270 volt. Input 230 volt AC, output 0 to 270 volt variable by using the variable terminal. The current capacity 8 ampere is sufficient, because you see your relay that you are going to test, right? That relay is 1 ampere relay, and I am going to use 25 by 5 CT. So if you pass 10 ampere of current, then it will be 2 ampere for the relay. And if you are setting the relay at 0.5 ampere, then your PSM is 4. Right? So up to PSM 4, you can test at full load current of auto transformer. But you see, overcurrent relay is going to operate within fraction of second. So that 8 ampere auto transformer, you can load up to 32 ampere for 3-4 seconds. Nothing is going to happen. So if you load up to 40 ampere, then N is equal to 5 means it will be 40 divided by 5, 8 ampere will pass. And if you have set the relay at plug setting is equal to 0.5 ampere, then PSM will be 16. So you will be able to test up to PSM 20 very easily. There is no problem. And you see, I have taken n is equal to 5, that is 25 by 5 CT. You can take 10 by 5 also. That will be yet better. I mean, this is just one case where I have shown n by 5. You can have a CT of 10 by 5 also. You can have a CT of 20 by 5 also. Then I have got one terminal T1 which I will wire on the panel. Right? This is the panel. And one switch S3, single pole switch S3, 15 ampere switch is enough. 15 amperes. Terminals are also 20 ampere terminals are enough, right? Rheostat, the value I have written somewhere. We will see the value of the rheostat. 5 ohms rheostat is there, right? Then C1 and C2 are the contactors. And what their contacts are doing, that we will be seeing. There is one terminal T9 you can see. If you take that two-pole switch which is there to terminal T9, then relay is disconnected from CT. And at 9 and 10 you can feed the current from external source. That means if you are using a test kit, ready-made test kit like CFB, you can test the relay also like that. And if you want to test like this using our test kit, you can test like that also. So complete freedom is there, right? So 9 and 10, it is not necessary that all overcurrent relay 9 and 10 is current coil. You have to see the terminal designation diagram of the relay. But that English Electrical Snyder, they have got 9 and 10 as the current coil. 7 and 8 is the potential coil. If it is a normal relay, non-directional relay, then there will not be any potential coil. But if there is a directional relay, then you will have to feed PT supply also. And if PT polarity is wrong, then relay will not at all operate, even if the plug setting is crossed. Then you will have to reverse the polarity, right? So many possibilities are given. 1 and 2 are the trip signals. And using that trip signal, you can trip the contactor, right? So a very simple circuit. I only assume that panel is available in the institute. Otherwise, you will have to spend for panel. Bakelite panel or wooden panel or any kind of panel you have to purchase from the market. That is a different thing. But I have not calculated the cost of the panel. Going further, circuit diagram is shown in figure. Circuit consists of auto transformer, emitter, rheostat, relay and test. Auto transformer and rheostat are used to control the current through the relay, right? Auto transformer is for course control. If you want to have a course control of current passing through the relay, and fine control you can do by rheostat. It's a variable rheostat, right? So that you can use. So course and fine control of the current. I've got a 5 ohm 500 watt rheostat. So I square R, if you say 500 divided by 5 is 100. 100 is I square. So 10 ampere of current you can easily pass. But if you pass 100 ampere for 1 second, nothing is going to happen to the rheostat, nothing is going to happen to the contactor, nothing is going to happen to the auto transformer. Therefore, you can test up to 100 ampere. And I've got 25 by 5 CT means 5 times less, means 20 ampere will pass through the relay. If I set the relay at 1 ampere, I can check the relay up to PSM equal to 20, which is more than enough. Because beyond PSM equal to 20, nobody would like to test. Because beyond PSM equal to 20, the time of operation is constant. So this is about the figure 1. The description of AC circuit is, you can use the local test set, or if you want to use the portable test set, as I told to you, you have to take the two-way switch to T9 terminal, which is brought on the panel, and you can externally inject the current if you so want to do that. Otherwise, you take it to city secondary and use our test set. S3 switch is specifically given. The reason for giving S3 switch is, I may want to test using the same panel. I do not want to use another panel. I can test differential relay also. So, if I want to test differential relay, then I do not want all this circuit. Then I will make S3 off and I will use T1 terminal, and T1 and neutral, that means auto transformer neutral, I will take, and through that I will feed to my differential relay external circuit, and I will test the basic setting and bias setting of differential relay. In some another experiment means, once we come to differential protection in theory, we will talk about differential protection in practical also. Right now we have completed the theory of overcurrent and earth fault. So I will be taking all experiments on overcurrent and earth fault only. Then I will be talking about differential. But differential relay can be tested on the same panel. No separate panel is required. So that is the that is how you can do. You can check up the time also. You can purchase the digital timer and you can find out the time of operation of the relay also. So how can you do that? For that you have to go for DC circuit. For that you have to go for DC circuit. And then timer circuit, as we will see. So we will check up the DC circuit. What do we do for our experiment? Push the push button PB1. You will have to purchase this, right? It is an NO push button and it is spring loaded. Spring loaded means if you push it, the contact will be on. If you leave your hand, then it will be off automatically. PB2 is NC button. If you push it, the contact will be open, and if you remove your hand, it will once again be closed. Right? Another PB2 is also there. I mean, there are two contacts of PB2 and C, right? And there is one more uh, contact PB3 that we will be seeing in another circuit, that is for reset purpose, right? So this is how you have to do. So what do you do when you want to test? Push the push button PB1. You can see, just see, push the push button PB1. Phase and neutral 230 volt is there. Once you push the push button, PB2 is NC, therefore C2 is energized. C2 is energized. Check up, check up. C2 is energized. C2 is energized means C2 1 will close. So let us see what C2 will do. How many contacts are there? So all those contacts have some purposes. So C21 you can see. C1 is an NC contact. Circuit breaker C1 is an NC contact. NC means it is normally remaining closed. When C1 is energized, it will open out. So now C2 has operated. So your circuit is complete. S3 is on. Your circuit is complete. Current is passing. Current will pass through overcurrent relay and it will operate and it will issue a trip signal. So that's how you can test the relay. So C21 is completing the current circuitry, right? So that is about C2. What is C2? 2 is doing? C22 is giving hold on path to PB1, because PB1 you are going to release hand. So once you push the PB1, C2 is going to be energized. C22 will be on. Therefore, even if you remove your hand, C2 will remain energized. It will not become de-energized. C22. C23 will show the red indicator. showing that your experiment is going on. Your circuit is on. Red means danger. Your circuit is going on. That is C23. C24 is coming somewhere. What C24 is doing? Let me see. C24. C24 is for timer. It gives the timer signal. C24 is giving the signal to the timer, so that timer starts. Once C2 is on, current starts passing through the relay, so timer starts, and when C15 operates, timer will stop. You will be able to measure the time of operation of the relay. C1 will become on when breaker trips, when relay operates, right? That we will see. So once again, coming back to this circuit, coming back to the DC circuit, C11, sorry, C21, C22, C23, C24, the purpose is we have seen, right? If you want to manually make the circuit off, push the push button PB2. So C2 will de-energize and current will stop passing from relay. That is manual making off of the circuit. But if you do not manually make off, then if because the current is passing and because the current is more than the plug setting, obviously current will be more than plug setting. You want to test. Therefore, relay will operate and it will issue a trip signal 1 and 2. That means 1 and 2 will close. 1 and 2 will close. Once 1 and 2 closes, closure of 1 and 2, PB2 is NC button, C1 will be energized. So another contactor gets energized. So C1 has got different contacts. C1 1 C11 holds on C1 because you see, once the trip 1 and 2 are closed, relay is going to operate. Relay is going to operate means uh, the relay will operate means the C2 will trip. Relay will going to operate means once the relay operates means, see, this is the DC circuit. Relay operates means C1. C1 operates. C1 operates means what? I go to AC circuit. C1 operates means what? C1 operates means, C1 operates means NC contact of C1 will become open. So current is disconnected from the relay. So relay de-energizes. So relay comes back. So 1 and 2 will become open. If 1 and 2 becomes open, then it will be off on. It's chattering, so that should not happen. So once the C1 becomes energized, C11 will hold on C1. C12 will give green indication. C12 will give green indication. That means circuit has tripped. Now we are out of danger. C16, there is some typographical error. C16 is an NC contact, right? So C16 when operates, red indication will extinguish. Means NC will become open and red indication will extinguish. So C11, C12, C13 and C14. C13 and C14, my dear friends. C13 and C14 is in AC circuit. C13 and C14 is in AC circuit. C13 is in phase and C14 is in neutral. So it discontinues the current to the relay. C13 and C14. C15. Where is C15? Let me see. Where is C15? C15 is in timer circuit. C15 is in timer circuit. Timer stops because relay is operated. Timer stops. Once current starts passing through the relay, timer starts. And once the relay operates, timer stops. Therefore, you get the time of operation of the relay. You note down the value of the current. You note down the value of the time. Plot the characteristic. Check up the error, whether everything is correct or not. You have tested the relay, right? This is what is happening with the relay. So control circuit, what I have told, I have explained here once again. When you push the green push button, C2 will be energized. C21 is providing power to AC circuit, that is circuit is completed. CT2, hold on. C23, red indication. C24, start pulse to timer, right? And C1, what about C1? C1 when operates, when C1 will operate? C1 will operate, let me see. C1, when C1 will operate? C1 will operate, when C1 will operate? C1 will operate when the breaker, I mean relay trips 1 and 2. C1 will operate when breaker trips. So when C1 operates, what C1 will do? What C1 will do? C1 will do so many things. C11 holds on C1, C12 will give green indication, C13 and C14 are NC contacts and they are disconnecting CB, C15 is for timer and C16 is for extinguishing red indication. That's what I told you. Power circuit can be made off by manual push button also, right? So that can be done. So this is how the whole experiment behaves. You can check up your relay. You set PS 50 to 200% in electromagnetic relay, it's 7 equal steps. 50%, 75%, 100%, 125%, 150%. 175%, whatever you want to, of 1 ampere, that is 0.5 ampere, 0.75 ampere, 1 ampere, whatever PS you want to adjust, you adjust. TMS 1, 0.9, 0.8, 0.7, whatever you want to adjust, you adjust. Then you take the reading, serial number 1, 2, 3, 4, 5, 6. What is the relay current? Emitter has been placed. See, emitter has been placed. Emitter has been placed in our circuit. Check up. Let us see. Emitter is placed in the circuit, right? Emitter is placed in the circuit. Emitter is there. This emitter, you note down the current. What is the current passing through the relay? So you have noted down the current, right? So current has been noted down, and then PSM. Relay current divided by PS is PSM. Top calculated. Top calculated is the formula. There are two formulae, mathematical equivalent formula is there. One formula for normal universe is 3 upon log 10 PSM into TMS, or another standard formula is beta upon PSM raised to alpha minus 1, where alpha and beta have different values for normal inverse, very inverse, extremely inverse, and long time inverse. This is what I have given in my module 3 of power system protection on ADAPT-Me. It is available in my book also, Power System Protection and Switchgear by McGraw-Hill Education. You can refer to anything, right? So that is calculated. You have to calculate using calculator, and measured means what the timer measures. So between calculated and measured, there will be some error. That error should be within limits, as I told to you. Between 2 to 4 PSM, error is plus or minus 12.5%, and from 4 to 20, plus or minus 7.5%. If it is so, relay is correct, and you can certify that this relay is okay. You have tested the relay in this case, my dear friends. So you have done the testing. For doing this, what is the cost of the panel? I am giving this also. For this is not for students. This is for faculty. This is for heads of the department. This is for principal of the institute, right? Because they will have to give an estimate to the account people that this is what I want and this is going to be the cost. You approve. Then they will call for quotations, and then they will rather procure things, and they will wire afterwards. So 2-pole MCB 16 ampere or 32 ampere, cost is not much different. You see, 16 ampere or 32 ampere, cost is not much different. But you can go for 16 ampere also, no problem. Auto transformer 8 ampere or 16 ampere, you can go for. CT 25 by 5, you can go for 10 by 5 also, I don't mind. PT usually 230 by 110 volt. Emitter I am telling 3, 0 to 5, because if you want to test an earth fault relay, you will need a lower emitter, 0 to 5. Overcurrent 0 to 10. And if you want to test overcurrent relay up to PSM, I mean up to PS2, then you may need 0 to 20 ampere also. So you may have to go on replacing meter according to requirement. So I assume that so many things, MCB, auto transformer, CT, PT and emitters are usually available in any electrical department of any engineering institute. So you will not have to pay for this. What is usually not available is contactor 16 ampere or 32 ampere with add-on contacts, because usually they give only 3 main power contacts and 1 NO contact. Usually. But if you ask for 3 add-on contacts, that means 2 NO and 2 NC extra will be available. So 4 NO, out of 4 NO, 3 power contacts plus 2 NC. So you get 6 different contacts. And such a contactor, what is the cost that I have written somewhere? Single pole switch 15 ampere, push buttons 2 NO. Such push buttons are also available. 2 NC. ऐसे push buttons भी बाजार में available है. The push buttons are available in the market. 1 NO plus 1 NC, that is also available. Green and red indicator lamps and digital timer. These are the things which may not be available in institute. So you will have to spend amount for that. What amount you will have to spend? These are not exact amount. This is an estimate. Recently I had purchased contactors. 16 ampere contactor is rupees 2000 per unit. Push buttons, indicator, switch may not be more than 200-300 rupees. Digital timer at the most may cost 2000 rupees. If you total it out, the cost would not be more than maximum 5000 rupees. 5000 is such a small cost that any institute can bear this cost. If institute cannot bear, you can ask the student to do the project work. If there are 3 students, then 5000 rupees between 3 students means about 1500, 1600, 1700 rupees per student. They will pay. They will, because they are getting knowledge, no? Other students will be doing experiment, but those students who are doing project work, they will be really wiring. And wiring as per the so to say the industrial norms. In BVM Engineering College, we have wired the laboratory with reference to industrial norms. So that can be done, and students are wiring. So I don't pay for wireman cost. I don't pay for, and I am of the opinion that you should give the practicals to students only. So students also will learn a lot. My students have learned a lot. Against this 5000 rupees, the CFB test kit now, it is an analog test kit. More or less, it is becoming obsolete. It is 2 lakhs. And Omicron test kit, latest numerical test kit. No doubt there are many facilities, I do agree, but it is 45 lakhs. No institute will be able to purchase. So with such a small cost, you can demonstrate a very good experiment to the students. So I think with this, we close our session today with a sentence. I like to use a sentence. When I was teaching, I was always telling 1 or 2 such sentences in the class, and many student friends have remembered this. One student who passed in 91 told me just before 2 or 3 months after 30 years that, sir, you were telling these sentences. He, in WhatsApp, he wrote 10 sentences. So after 30 years, he was remaining these sentences. Alert and vigilant living itself is a sadhana in the true sense. Sadhana is not sitting, closing eyes, or uh, speaking Ram, 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 Shiv, 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 Krishna, 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 Krishna. That is not sadhana. Doing practical nicely by understanding the practical fully when you are learning, right? When a teacher is teaching with full of his capacity, that is sadhana. I tell, Osho is telling that there are three types of questions. One question is question of a child. He does not want answer. He asks this question, what is this? He shows the chair and he asks to his parent, what is this? Parent says chair, but by the time parent says chair, he is gone. He is not worried about the answer. He does not want an answer. That is one type of question. Another question is jigyasa. You want an answer. You want to learn. Teacher wants to really teach. He teaches for full 1 hour. He uses full of its ability, full of his ability. So the first kind of question is what is known as tamas. Sattva, Raj and tamas. Second kind of question and answer that you want to really learn. You have an inquisitiveness to learn. That is rajas. That is not yet sattva. What is sattva? Sattva is what Vivekananda had. He wanted to know whether the God is not there or not. At 2 o'clock night in river Ganges, Ganga, where the water is fully cold, he swam, तैर के गए वहां और he met Devendranath Tagore. He was the philosopher of that time. Dwar khatkhataya. He just knocked the door. Devendranath came and he asked Vivekanand, not Vivekanand, that time he was Narendra. He asked, is God there? Can you show me God? Devendranath says, at 2 o'clock? Why are you asking at this time? But please hear, but by that time, that fellow had gone. He told that whether you will answer, your answer is a problem of life and death for me. If I find God, I will live. If I don't find God, I will die. It's a question of life and death. It's a question of life and death. Swami Ramtirth was doing an example. There were 10 students doing an example. He did not get an answer. He tried 7 times, 6 times, 8 times, 9 times. 10th time, he was keeping chara with him. क्या बोलते हैं उसको? The weapon with him. And he wanted to kill himself. So other students were seeing. 10th trial he got an answer. Other students told that why this weapon? He told that had I not get an answer, I would have killed myself. I don't mean to say, my friends, that you kill yourself, but that is sattva. You want an answer because it's a question of life and death, alert and vigilant living, perfection in your work. Mother of Sri Arvind, she was also telling that perfection is sadhana. So, my dear friends, you do sadhana when you do an experiment. So, friends, with that, this is the last slide. I have been telling that you remember adapt me. You read this experiment. You prepare this experiment in your institute. You ask many people to prepare. you share this video to as many people as is possible, because many people will learn and many institute will be able to do a real experiment. And I can dare assure you that this will consume full 2 hours and full practical 2 hours, nothing theory. So thank you, my friends. Good day. I cannot tell good night, yes, because my night is 12 o'clock. So yet 4 o'clock are there. I mean 4 hours are remnant. Enjoy. But please, please, I repeat that remember this word, adapt me, and share this, subscribe our Adapt Me channel in YouTube, like my video and share to as many people as possible, because sharing knowledge is the best thing. There are two good things, sharing knowledge and sharing food. आप किसी को कुछ खिलाओ. If you give food to people, that is very good. And if you give knowledge to people, that is very good. Money is not good, because money will buy wine and will waste money. Right? Money is not main thing. What is main is knowledge and food. खाने के लिए किसी को ना नहीं बोलना. If somebody asks for food, don't deny. If somebody asks for knowledge, don't deny. If you know, please share. I am sharing, my dear friends. Thank you. Good day.